running both our spec DU800s and our Bio. So this program for driving the PCR machine is the software package which accompanies this. This actually can run standard PCR as well, and it doesn't need the computer to drive it. What the computer is used for is for qPCR because it actually puts the data together for not only the optic measuring of this, the detector, which is this big old, huge bonnet on the top. There's a fluorophore detector there that measures after every cycle. And what kind of data you'll pull up, I'll show you this next door when we get in there. It looks like growth curves, like bacterial growth curves. They're exponential growth curves. But I've set this up in such a way, and running through the actual setup is not necessarily beneficial for you guys because there's so many different PCR programs and machines and stuff that the learning curve for the software is absolutely insane, and it doesn't pay off. So I can show you how to use this stuff, but it's probably not going to be the same that you guys are using. What ours allows us to do is actually detect the sample in the strip tubes, and then I can designate what's what in each sample. So 1, 2, 3, 4, 5, 6, 7, 8, all the way through 14, and the last two I'm using as controls. And so as the data comes up, it'll actually label that up for sample 1, 2, 3, 4, and you can get all your data based on your number. We can set the plate type, we can set the amount and the volume, and if we wanted to use other things. One of the things I have programmed in here is a melting curve. As it creates and finishes that PCR cycling, now you have a whole bunch of amplicon products. The data is not done there just yet. For standard PCR, it would be. But what this does as part of the qPCR program is that it will ramp it back down to the lowest temperature, which is about 50 degrees. And in 1 degree increments, it'll start to measure, right? And it'll take 1 degree snapshots of what the fluorescence is. The idea is that after it hits 90 degrees, 94 degrees, everything is denatured, right? During the denaturation process, we're losing the overall fluorescence units, relative fluorescence units. And so, say for example, you have a lot of product which has a melting temperature of 82 degrees. You're going to see nothing, and then 82 degrees, everything will denature based on the ATG and C melting calculation. And that'll be the indication that there's a single band there. And then maybe another one at 87 degrees, right? And so it's kind of a neat way to actually analyze the data in terms of the melting curve. And we'll talk a little bit more about that and how that can be useful too. So I programmed it in, and all I'm going to do is hit start, and hopefully it'll start to read our data. That's like music to the ears whenever I hear that stuff. Because it has these two programs that go in there, and it says, this is not calibrated for dome, this, and it's like, oh, yes. But now it's starting to run. And this is the actual real-time read. The real-time read goes through the cycles, and it'll allow us to detect that after every cycle how much relative fluorescent units are detected, right? And so we should start to see something growing up there over time, if the PCR is working. So keep our fingers crossed. The PCR itself, standard PCR for this, it's really quick. 3-step cycles, 30 seconds, 45, and 45. We're going to run this for 35 cycles and then see what we get at the very end of that PCR mix. So by the end of lunch, I'm hoping, let's see, 35, 3, we'll see, sometime in the middle of the afternoon, we should get this data for the melting curve as well. But we'll come in and periodically check to see what's happening here and making sure that we get some signal amplified. Now this PCR is a really cool one because this actually allows you to visualize the step increments for the temperature. 94 is high. This is a hot start. 94 for 30 seconds, which is the first of the 3 steps. Then down to 52 for the annealing and 72 extension. Repeat back again for 40 cycles. Oh, the 72 is at 0 because it's wrong. Thanks. Look at that. I just reprogrammed this thing, so let's turn this on.
Oh,
Well, it would work because.
we would keep
Yeah,
finger
thanks for
crossed.
yeah. Okay, so let's get out of here and I'll show you how to reprogram this. Okay, 1 second. Oops, sorry guys.